All right, MSDOSX, welcome back. Lecture 6 today, we're going to actually start writing some apps and kind of learning how to build an interface for, today we're just going to talk mostly about Mac. And on Tuesday we'll cover some of the differences between Mac and iPhone. You'll actually learn there aren't very many, which is pretty cool. But today we're going to talk mostly about Mac and kind of motivate how the designers of Cocoa made a lot of their design decisions when coming up with how to create interfaces and link together. Yes? No. No attendance. Which is good for people that aren't here, because there's a lot of people missing. I assume that's because I'm webcasting, but I don't know that for a fact. Okay, well, let's get started. Are you going to work today? Oh, come on. There we go. Okay, so the first thing I want to talk about is the model view controller paradigm, which is a design paradigm that's used pretty extensively throughout apps on the iPhone and Mac OS X to kind of separate the different parts of the logic of your application, so that way things are really modular and can be changed really quickly. And we'll see how to do that. And over the next couple labs, you'll get a really concrete example of why MVC is a really powerful paradigm. But the idea is there's three parts. There's your model. This is basically where your application state is. It doesn't really know about the UI at all in the perfect case. An example is if you're writing, I think our first lab actually, we had this fraction class that allowed us to do arithmetic with fractions. And it didn't know about the fact that it was in this app. It just knew, okay, I know how to do math with fractions. So models, in that sense, they're kind of dumb. They just know how to do whatever manipulations of data that they know how to do, but they don't know how it's getting presented on screen. The opposite side, of course, is the view. This is the part of the application that your user is going to see. This is where all your UI code goes. Its job is essentially to display what's in the model in some useful way to the user. And there's lots of ways to do that, and that's kind of the whole challenge of user interface design, is to decide how to show the information you want. In general, views don't store any data. Ideally, that should all be kept in the model. Under the hood, views tend to cache a little bit of stuff to keep track of their views, so that we don't have to. So redrawing isn't quite so expensive, but that's not super important. The idea is that a view is again pretty dumb. It doesn't know much about the data, but it can ask the model for data, and then it displays that on the screen. And in between those is the controller, and the controller's job is kind of to be this middleman. Anytime the model changes, it tells the view, hey, you need to refresh. Anytime the user does something on the view that hopefully ideally is going to change something in your model, the controller will say, hey, something happened, go change the model for me, please. So you can kind of imagine these are our three parts of our application, and if you wanted, you could have these communicate in all kinds of crazy ways. But you should really kind of visualize this brick wall between the view and the model. Ideally, they shouldn't communicate directly. They should really, anytime they want to make any changes, they'll notify the controller, which will then notify the model, and vice versa. And can anybody think of a reason why this is a good idea?
What if your model needs to change it some way?
Exactly. So the cool thing about this is, if your view was tied directly to your model, any changes in your model need to be immediately changed in your view. And specifically, if you change the way your model is implemented, that probably means your view needs to figure out how to communicate with your model. Instead, you can leave your view with the model view controller. If your model's implementation changes, your view doesn't actually have to change. The controller can change how it communicates with the model, so that way you don't have to touch your view code at all. Similarly, if you decide, I actually want to display this differently, you don't need to change the model to figure out how to display stuff, just the view needs to change, and then how it communicates with the controller changes. So it provides this really great modularity. And as we'll see in this lab and the next lab, we're actually going to use a model for an iPhone app and a Mac app, and we'll use the same model, and you can see that we don't change very much code to go from one view to the other. So it's great for portability. Okay, so rather than try to explain to you how to make a UI using an Xcode and interface builder, I'm just going to show you. So I'm just going to make a new simple Cocoa app, just using all the default stuff, and it's going to call it Slider, and you'll see why. And I'm probably going to want to be in presentation mode. Okay, so this simple app gives us a couple of classes to play with. The file we're interested in is actually this main menu.xib. Zib is how it's often pronounced. This is kind of a graphical representation of the different parts of the application. So I can take a look at this window, and here I have a window. Man, this is small. Okay, so here's my window, and I can, oh god, this is going to get really small. So I can, do something like, and there's a bunch of objects in the library down here. You can scroll through. There's quite a few different kinds of widgets we can pull in here. Let's just, for fun, drag in a button, and then I'll save this and run this application. And let it compile. And now I've got this app with a button in it. So that's pretty cool. So you can see it's pretty neat. I mean, it doesn't do anything, but it's pretty cool that I can lay out my application graphically and then just have it work. But that's not really what I'm interested in here. So I'm going to, certainly take the time to go through all these and kind of get a feel for what elements you're allowed to put into your user interface. I need a label, and where is the slider? Okay, and I'm going to have a horizontal slider. Okay, and we can see up here in the, I forget what this pane is called, but this is kind of your inspector. So there's multiple panes. There's the leftmost one here is the identity, which kind of is what it is. So if we click on the slider, we can see it's an NS slider. If we had our own custom slider class, we could change it there. The next one is what do they call it? The attributes inspector. So there's a lot of different attributes we can set on this one. If you make it circular, it kind of is a little wheel you can spin around. That's not really what I want. You can, and obviously a lot of these are all specific to the different controls, but I'm just going to let the value go from 0 to 100. So you can see the minimum's at value is 0, maximum's 100, and it's currently set to 50. All the default stuff's pretty good. And I'm just going to have this label be 50. The idea is I'm going to have this label just show whatever the current slider's value is. Okay, so we run this again, and we have the slider. We can slide it back and forth, but not much else. We need a little bit of work to figure out how to actually get that label to change, and how to get the slider to notify that something had changed. So let's motivate how we did that. Oh, have something else first. Okay, well that's fine. Okay, so I should show this, but so by default, views don't resize or move at all anytime their parent view resizes. So on Mac OS, this is anytime the window gets shrunk or resized. Your window, of course, doesn't resize on iPhone, but it does auto-rotate. It does rotate, so kind of the same logic applies. I'll talk about that next time. And there are several properties that we can set on views that allow to customize how it resizes relative to its parent. And then Cocoa does everything. It does all the math for you. You don't have to figure out how it resizes. You just set some properties on it, and it does the work for you. And with Lion, there's actually a really cool, even better system that I'll mention briefly. But the system that we've had since before Lion is called struts and springs. So imagine that this blue square here is our subview that we're interested in, and the white square is its parent view. So we're gonna right now, if I just left it as is, so these are our strings and struts. There are two springs that kind of spring through, that kind of specify how it's going to resize, and then there are 4 struts that specify how it moves relative to its parent view. So we'll go over these one by one. So there's a strut on the top that says anchor to the top, which means that no matter what, keep the same distance from the top as it is right now. And similarly for the left and right, keep the same distance from the bottom, keep the same distance on the left and right. We can also specify springs, which say, if it's set, I want this to be flexible in its width, or flexible in its height. Interestingly, it's somewhat undefined what happens if you set top and bottom anchored, but not resize. I think it just picks one size to stick to, and then you're kind of stuck with that. So usually if you set both, if you want it to be anchored to the top and bottom, you need to make it flexible height as well. So that's what we had prior to Lion. With Lion, there's this really cool system called auto layout that's constraint-based. I'm not going to talk a lot about it because it's kind of complicated and there's a lot to it. I don't think Apple's publicly released, there's a talk about it, but I don't think they publicly released it yet because maybe they have. But I think it's just for developers at this point. But it's really cool. It's a way to... It basically, Apple has this great guide called the Human Interface Guidelines that very precisely defines how different controls ought to look next to each other, which includes things as precise as things ought to be 5 pixels away from the edge of the window, and these two different kinds of widgets have to be 2 pixels apart, and so on. And I should have shown you some of these. I'll go when I go back into Interface Builder. I'll show you. In fact, I'll do that now. And Interface Builder knows all of these guidelines. So you can see if I try to move this around, we'll get these blue guidelines, which say, okay, so these two tell us that's kind of the standard Cocoa spacing relative to the edges, and you can also see that it's given us this one here to say that these two are aligned in the center. And it's pretty nice that you don't have to memorize the Human Interface Guidelines and memorize all those kind of weird pixel numbers and all that. Interface Builder knows all those and can help you align things properly automatically. And with auto layout, it basically takes all of these constraints that are defined in the HIG and just applies them in the way it thinks it makes the most sense. But I'm not going to talk about them in any great detail because it's really complicated. Just to kind of get, these are some of the highlights of why auto layout is nice. There's a lot that you can do with strings and struts. There's also a lot that you cannot do with strings and struts, and that prior to auto layout required a lot of manual code of manually resizing your views every time the window changed size. And with constraints, things can actually be more dynamic, and you can specify really complicated relations between the different controls. You can also lay things out in code, and they have this really cool ASCII art language for defining the relationship between different controls. And it generally allows you to be more flexible. I think this is really cool. It makes localization really nice. So if you have, they give a great example of this alert view in English that has a long bit of text and then names on each of the buttons on that alert. And then if you put it in German, those words are a lot longer, but yet it resizes naturally, and everything just fits. And what's even cooler is that if the language is right to left, it actually realigns everything the opposite way so that it reads right to left rather than left to right, which is pretty nice. And there's a lot of different relationships that you can specify in those. And I'm again not going to cover these in any great detail. Feel free to look them up if you want. They're pretty cool. Okay, so to give a little motivation, if you're thinking back to our demo, we have these controls on our interface. Now we need to somehow tell some piece of code something happened. And how do we do that? So I kind of hinted at this a couple lectures ago, but the solution that they came up with is to use what are called outlets and actions. The idea is, and these kind of work. So there's actually two problems. There's one is when a control has something happen to it, we need to notify some code that something happened. It's also often the case that our code needs a reference to some object in our interface. And outlets and actions allow us to do those two things. Outlets are a way